Okay, chapter 6 is all about similarity. And as I mentioned in class, we're going to move chapter 5 to after chapter 6. We're going to flip-flop them, and I'll talk a little bit more about why I did that. But we are not covering chapter 5 now, but we will. Chapter 6 is about similarity, and 6.1 it talks specifically about ratios, proportions, and geometric mean. First of all, reviewing what a ratio is, it compares two numbers. It can be written several ways. Ratios do kind of look like fractions sometimes. You can have the two dots between it look like a fraction, or have the word TO between the two numbers. In guided practice on page 356, when you simplify a ratio, most of the time you simplify it just like a fraction, dividing the top and bottom by the same number. However, you do have to make sure that you have the same terms. With this first example, the given ratio is 24 yards over 3 yards. So we can divide both the top and the bottom by 3. 24 divided by 3 gives you 8. 3 divided by 3 gives you 1. The difference with ratios is not only do you have to have the same terms, but you do have to have two numbers. If this was just a fraction, 24 over 3, this would simplify to 8. Because it's a ratio, we do have to have 8 to 1. So those are the two big differences. The other example, again, this is from Guided Practice on page 356. The given ratio is 150 centimeters to 8 meters. So notice we have two different terms. If you're not sure what the conversion rate is, you can always Google it. In this case, 1 meter and 100 centimeters mean the same thing. So this is my conversion rate. So I took my given ratio, multiplied by the conversion rate, and got 150 over 600. They have the same unit. So now when I divide, 150 divided by 150 gives me 1. 600 divided by 150 gives me 4. So this given ratio after the conversion and simplifying becomes 1/4. This is a more specific problem. So this tells us, and you can look in your books, this is on page 357, Guided Practice. It tells us that the room has a perimeter of 48 feet. The ratio of the length to the width is 7 to 5, and we're asked to find the length and the width. So this is a direct application of what I was just talking about. First thing I need to do, because this is the information that's given to you, first thing I need to do is define the length and the width. If it's 7 to 5, it follows the same order. This is the length, this is the width. So the length I'm going to call 7x, and the width is 5x. We should know that the perimeter of a rectangle is 2 times length plus 2 times the width. That should be familiar to you. So I'm using that, and I'm going to plug in what I know. I know the perimeter is 48. I know the length is 7x. I know the width is 5x. Solving my equation, multiplying, combining like terms, x is 2. But be careful, make sure you're answering the question. It asks us find the length and the width. Well, I only found x. So going back up here, when I plug in x, 7 times 2, the length is 14 feet. Width, 5 times 2, the width is 10 feet. There's a lot of very similar problems with a similar setup with this idea. I have another example with triangles. Being that we spent a lot of time on triangles, we should know that the sum of all the angles of a triangle add up to 180. This says the triangle angles are in the ratio 1 to 3 to 5. Those are the 3 angles of a triangle. So we're going to define it. We're going to use this to define those 3 angles. The first angle is just going to be x. The second angle is 3x. And the third angle is 5x. That x represents that unknown factor to figure out what the actual measurement is. So we're going to use these 3 angles, x plus 3x plus 5x, and that has to add to 180 because we know it's a triangle. When we solve this, we find x is 20. They're asking us to find those angles. They're telling us that this is the relationship, but we don't know the actual angle measurements. So when I solve my equation, I know angle 1 is x, so it's 20. Angle 2 was 3x, that's 60. Angle 3 was 5x, so that gives me 100. And double checking, 100 plus 60 plus 20 does give me my 180 that I need to have for a triangle. Solving proportions. Proportions are made up of 2 ratios. You can see this for an example, and this is on Guided Practice, page 358. So when you solve proportions, you use cross products and your basic equation solving skills. So what I mean by cross products, this is my given proportion. cross products means these two will be multiplied together and these two will be multiplied together. So you can see how I set up my equation. Y minus 3 times 14, that's here. Y minus 3 goes in the parentheses because it's times 14. 14 times everything in those parentheses. The other cross product is 7 times y. And notice I put an equal sign between it. So one cross product equals the other cross product. I distributed, and then I moved my 7y over, moved my 42 to the right, divided out, and we got y equals 6. So the directions were to figure out what y is. This is just a simple equation solving kind of thing. So the new idea for today is the geometric mean. And this is something you haven't done before. You have probably done ratios and proportions. This is new. Not a terribly hard idea. Geometric mean, this is the y, this is the basic. When you're asked to find geometric mean, what I'm asking you to do is multiply, then square root. This is y. So if you have two ratios where one cross product is the same, look what happens. X times x is x squared. A times b is ab, a times b. When I square root to get that x by itself, look what happens. This is a geometric mean, and this is why we're doing geometric mean. So generalized questions or examples for this. Again, we're using the guided practice from your book. So they say find the geometric mean of 12 and 27. Look what I did. Multiply, I got 324. Then when I square root 324, I got 18. So 18 is the geometric mean of these two numbers. Let's look at a couple more examples. Find the geometric mean of 18 and 54. I multiplied them and got 972. When I square root them, this is not a perfect square. I haven't addressed this a whole lot, but I want to start talking about it. I won't put problems like this on your quiz, but I want you to start thinking about simplest radical form. So when I square root 972, I get a decimal. I don't want decimals because we lose some of our accuracy. So what I want you to do is think about perfect squares. And perfect squares are the result of multiplying a number by itself. So perfect square list looks like this. I'm not going to write all of them, but at least you'll have an idea of where they're coming from. Looking for numbers that are perfect squares that go into 972. Well, I spent some time on this and I found that perfect square is 324. I broke this down into two numbers, one of which is a perfect square. 324, when I square root it, I got 18. 3 cannot be square rooted to get a whole number, so I left it under the radical. This is simplest radical form. Let's look at one more. Find the geometric mean of 16 and 18. Multiplied and got 288. 288 is not a perfect square. When I square root it, I get a decimal. So I broke it down. 144 is a perfect square. So I broke 288 down into 144 times 2. 144 square rooted is 12. The 2 stays within the radical. This is simplest radical form. I will keep talking about it. I won't put problems like this on your quiz, but I will put problems similar to this on the quiz. Your homework is listed on the board over there. And as always, your homework answer key is posted, and I'll always answer questions before you take your quiz next time.